Welcome to Note 1.1b for Math 8. This note is the product of powers and quotient of powers. So now that we understand what exponential notation is from Note 1.1a, we can use it to perform operations with exponents. Question 1 asks us to expand 10 to the 6th power. All we need to do here is to write out what 10 to the 6th means. And so what we would have is 10 times 10 times 10 times 10 times 10 times 10. So it means 10 multiplied by itself 6 times. We don't need parentheses here because we don't have a negative number, but it's okay if you have parentheses. In question number 2, it says to expand 10 to the 3rd power. So what I'm going to try here is to pause the video, and I want you to try this on your own. Come back, check your answer, and we'll see how you've done. Welcome back. Hopefully you have 10 times 10 times 10. Alright, the reason we have these two expanded is that it will help us answer number 3. So in question 3, what we need to do is expand 10 to the 6th power times 10 to the 3rd power. So let's go on ahead and do this. 10 to the 6th power is 10 times 10 times 10 times 10 times 10 times 10. Okay, we'll pick a different color here. And 10 to the 3rd power is 10 times 10 times 10. And just so that you can see right here, that is the 10 to the 6th power, and it's being multiplied by the 10 to the 3rd power right here. Okay, so I didn't change the question, just expanding things. So at this point, how many 10s do we have? Well, let's count them here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Using exponential notation, what we have here is 10 to the 9th power. So if you write that out, hopefully you can see a shortcut if you simply look at the exponents. Okay, so again, 10 to the 6th power times 10 to the 3rd power equals 10 to the 9th power. You have a 6, you have a 3, you have a 9. Wonder if you can figure out a shortcut here. Why don't you take a second, think about this, and if you're able to figure out a shortcut here, it will be really handy when you have large exponents and you don't want to write them all out. Okay, at this point the goal that I'm working toward is to try and fill out what's in the box below. Before we get there, let's try to apply the same process to variables. Let's go to number 4. Number 4 says expand a to the 4th power. This gives us a times a times a times a. Number 5 says expand a to the 5th power. So we have a times a times a times a times a. We'll use these two questions to answer number 6. It says expand a to the 4th times a to the 5th. Okay, well, let's write this out. A times a times a times a. I'm going to cheat, and I'm just going to copy and paste down here. So now we're multiplying by a times a times a times a times a. And we'll try to figure out, okay, what do we notice? Well, again, right here, we have a to the 4th, and that's multiplied by, right here, we know this was a to the 5th, right? Okay, how many total a's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I guess this would be a to the 9th power. So at this point, I just want to call your attention to the 4 here, the 5 here, and the 9 there. Notice a connection. Hopefully you at this point do. And then one other thing. Right here, this is just a coincidence. Sorry about that. The 9, just a coincidence. It's not always going to be an exponent of 9. So if you haven't caught on by now, what we could say is if you are multiplying the same bases, all we need to do is add the exponents. So let's fill in the blanks below. It says when you find the product of two algebraic expressions with the same base, you can add their exponents and use this exponent with the same base. If you notice back in question 3, the tens didn't turn into 100 to the ninth power. It was still 10 to the ninth power because all you really have are a bunch of tens. So the tens stayed as tens. The a's in the next few questions stayed as a's. So the base always stays the same. So if we were to finish what I wanted to write in this box, the general form would read a to the m times a to the n is equal to a to the m plus n. So let's apply our shortcut. We call this the product of powers because we're multiplying two powers to the next few questions. So in number 7, we have negative 4 to the second power multiplied by negative 4 to the third power. And so keep the base the same. We have negative 4, and we must have parentheses around that. And it's all being raised to the fifth power because 2 plus 3 is 5. In number 8, it's a little tricky because it has an invisible exponent on the 3, but the 3 is there one time, which means the invisible exponent is 1. So we have 3 to the first power right here. So our final answer for number 8 is 3 to the 7th power because 6 plus 1 is 7. Press pause, or we'll pause here, try number 9, and then come back and check your answer to mine. Hopefully, in number 9, you came up with a to the 32nd power because 23 plus 9 is 32. Now let's scroll down and see what happens when we divide. Number 10 says expand 5 to the 6th power, which means 5 times 5 times 5 times 5 times 5 times 5. As we've done before, let's now move on to another question. We'll use 5 to the second power, which is 5 times 5. Those two questions set us up for number 12. In number 12, it says to expand 5 to the 6th divided by 5 to the 2nd. So let's write it out slightly different this time. Let's write it out as 5 to the 6th over 5 to the 2nd. Our answer will end up being just like we did before, 6 5s up top and 2 5s in the bottom. Since we have 5s in the top and 5s in the bottom, they cancel out because 5 divided by 5 is 1, right? So we have a cancellation here and here. We have a cancellation here and there. Now anything times 1 is itself. So in this case we should get 5 to the 4th because we have 1, 2, 3, and 4. We have 4 5s, so 5 to the 4th. So hopefully you can figure out what the trick is, and that trick is going to be connected to the 6, the 2, and the 4. Let's try one more time and see if you can figure out what this trick is in case you haven't yet. I want you to notice in number 13 it says expand y to the 7th, and so that is 7 y's. Number 14 says expand y to the 4th. That gives us 4 y's. This will set us up for number 15, where it says expand y to the 7th divided by y to the 4th. And then it says, what do you notice? So again, we'll write this out as a fraction. We have some cancellations that happen here, 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 and here. And remember, anything divided by itself is 1, and anything times 1 is itself. So we are left with 1, 2, 3. 3 y's, or y to the 3rd. Again, the connection here is going to be between the 7, the 4, and what we had as our answer, the 3. If you haven't figured it out yet, what we are doing is subtracting the exponents. So let's fill in what we have here in the box. When you find the quotient of two algebraic expressions with the same base, you can subtract their exponents and use this exponent with the same base. So, the generic form, a to the m divided by a to the n, gives us a to the m minus n. So, in number 16, we have 2 to the 9th power divided by 2 to the 6th power. The bases are the same. They both are 2's. And so all we have to do is subtract their exponents, and we get 2 to the 3rd, because 9 minus 6 is 3. In 17, remember there is an invisible 1 right here with that second negative 7. Because we're dividing, we get negative 7 to the 4th power. Remember, because it's a negative base, from last note, we must include parentheses. Number 18 is tricky. Notice the 35 and the 5. These are called coefficients. I'll circle those for you right here, a 35 and a 5. Those are called coefficients. They are not the exponent. They are not the base. Just deal with them like you would normal numbers. So since we're dividing, all we have to do is divide 35 by 5, and we get a 7. All we have to do now is subtract the exponents for the bases that are the same. So we have x's and y's on the top and x's and y's on the bottom. You can only subtract the exponents for the x's together and then subtract the exponents for the y's together. We should get x to the 2nd because the 4 minus 2 is 2, and y to the 4th because 7 minus 3 is 4. Hopefully you understood what I taught you. Please make a note of any of these questions that you don't understand, and you can ask them in class next time I see you. Thanks for watching.